Okay, the product and quotient rules. First of all, the product rule. Product rule. If you have two functions that are multiplied together and you want to take the derivative, then this is the formula. First derivative with respect to x of the functions f and g multiplied together gives you, take the derivative of the g function, multiply it by the function f of x, and then add the g of x function and multiply it by the derivative of the f of x function. Here it is with an example. So think about this part as being one function and this part being your other function. What you do is you take the derivative of the g of x, which is just 3, and multiply it by f of x, and then you take your g of x function and you multiply it by the derivative of the other one and simplify. We can verify this by taking this original function and foiling it out and then taking the derivative of that. So I'll leave that for you to try right now. So pause the video, try it, and here's the solution. Did you notice my mistake? Yes, with my notation. I needed to have this here. Alright, here's another example. Notice when I'm taking the derivative with this example, I'm taking it with derivative with respect to the variable t. So this is my one function and this is my other function, and when I get the answer to this, I have 4t cubed e to the t plus t to the fourth times the derivative of e to the t, which is still e to the t. If you like, you can factor this out and simplify it a little bit, and you can get t cubed e to the t and left over 4 plus t, or t plus 4. Another rule is the quotient rule. So if you have division of two functions and you're trying to take the derivative with respect to x, you get g of x times the derivative of f minus f of x times the derivative of the g function, all divided by g of x squared. This is a much more complicated formula to remember. Take a look at an example of this. If you've got some function and it's built as a rational function, so this is one part, think about it as your f of x, and this is your other part, your g of x. Then, when I take the first derivative, notice the proper notation this time, then I get g of x, which is x minus 1, times the derivative of the top part, minus the top part, times the derivative of the bottom part, all divided by the bottom part, g of x squared. And we do need to go ahead and simplify this, so this is 2x minus 2 minus 2x all over x minus 1 all squared, or that. Alright, one more example. Okay, we're going to find the equation of the tangent line to our function at the value x equals to 1. So we're going to build a y equals mx plus b, a linear tangent line equation. To do that, we first of all need to know the slope. To find the slope, we use the first derivative. To find the derivative, we need to use the quotient rule. So you get the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. We actually want to know what that is when we evaluate it at 1, so I substitute 1 in everywhere. I get 4/3 go ahead and actually do that on your calculator or by hand. Then I know at least my function needs to look like this. My f of 1 value I can calculate using my original equation. I calculate that to actually just be 1, and my slope is 4/3. And I have the point slope equation of the line that's tangent to my function at x equals 1. Go ahead and verify that graphically. Put this in as y1, put this in as y2, and take a look and see if you actually have the tangent line at x is equal to 1. I checked it using Wolfram Alpha. Yay! Our result is correct, and there's the graph. Alright, good job.